Okay, so today I'm going to cover color rendition, what it is, how do we measure it, and how do we practically use it. So color rendition, why do we care? Well, as designers, we make things that are subjective, but we use tools which are objective. And so color rendition allows us to take our subjective design and evaluate these objective tools to determine, are they actually the right tools for the job? Is it going to be suitable for our design needs? So color rendition bridges this gap between our subjective design and the objective tools. And when we are measuring something, anytime we measure something, we need references. We need to measure against something. It's always measuring this against another object. And so in lighting, in color rendition, how do we evaluate it? We need to look at two things. We need to look at reference light sources and reference objects. So we're going to first start with looking at the light source. Now, light source comes in many different types, from your natural lighting to different lighting technologies, incandescent, fluorescent, LEDs. And then we also look at the objects. And there's many types of real world objects that all have color and texture. So that ranges from fabric to skin tones to things found in nature or artificially made. So we need to find references for both the light source and references for the object. So we're going to first start looking at light sources, the reference light source. The reference source is a black body radiator. Now, before I get into what that is, I just want to point out the question. Have you ever thought of the term color temperature, and why does color have anything to do with temperature? And what does light have to do with how hot something is? That answer actually lies in quantum physics. So it turns out any object that is above absolute zero is emitting light. It's radiating photons in the electromagnetic spectrum. Anything that is above absolute zero is emitting light. However, this light we may not see until the object gets to a certain temperature. And so you may have seen this in the real world when it comes to fire, the sun, or something that is glowing hot. The reason why it is glowing is because this thing has gotten to enough heat in Kelvin temperature that is actually emitting photons at a wavelength that we can visibly see with our human eyes. So again, every object that is above absolute zero is emitting light, but we just happen to see the light when it gets hot enough. And so the color temperature, you'll often see it referred to something degrees Kelvin. It really is an object at that heat level that is going to generate that type of light. So what a black body radiator is essentially an ideal light source that is black body, meaning that it does not reflect any light going into it. It's going to absorb all the surrounding light. And the only light that it emits is purely based on its own heat level. And there are some objects that are very close to black body radiators, such as filament bulbs, incandescent bulbs, or the sun. So those things, they emit light purely because of their own heat. And this is why you have color temperature. Now, I got to warn you about some potential confusion. You may have heard the term warm white and cool white, and you've also heard color temperature. Now, these things are related, but they're actually inversely related in that they're backwards. So warm white refers to light that has a yellow or red hue to it. And we call it warm because we associate it with fire that feels warm to us. And cool white typically is something that has a bluish hue, and we associate it with something cool, such as ice, right? So we call it we call it cool white. However, when you map on to them the actual color temperature in degrees Kelvin, it's reverse. So warm white has lower color temperatures, such as 2700 Kelvin or 3000 Kelvin, And cool white actually has high color temperatures, such as 6,500 Kelvin. So it's backwards. So definitely just remember this warning that the qualitative description of warm white and cool white is actually completely backwards from the quantitative description of the color temperature. All right, so now here's another aside about what is correlated color temperature. And you'll see this abbreviated as CCT. The reason why it's called correlated color temperature is because you have oftentimes light sources that emit light not because of its heat. So such as LED or fluorescent, they emit light of a certain color, but it's called CCT or correlated color temperature because we're trying to correlate that to a black body source that would have been needed to heat to a certain color temperature in order to generate the equivalent light. So that's like you have a white LED that's generating something at, let's just say 3000 Kelvin. It has a specific light color coming out of it. That color is equivalent to a black body radiator that actually is heated up to 3000 Kelvin to emit the same color temperature of light. So this is called CCT because it's correlated. It's not actually getting that hot, but it is generating a light source, a light output that is equivalent to an object that would have needed to be that hot. Okay, so now we've covered the reference lights. Now let's look at the reference samples. So we've taken real world samples, which ranges from things that you would see in your daily life, such as fabrics or natural materials or skin tones. And we've kind of taken the average of a lot of those and made representative color samples that allows us to test our lights against. And so when we are looking at the metric that tests how a light mimics the reference light, that is currently using the metric called CRI, or the Color Rendering Index. And essentially what that is like is we're taking a reference source, such as, let's just say the sun, which is very close to a black body source. Let's say this sun is at 3000 Kelvin, and it is being, and that light was calculated to hit these color samples and produce a certain amount of color results, illumination results onto these test devices. And then we take a test light and we hit the same samples and basically see how well does this test light reproduce the same colors compared to how this reference did. The closer the sample reproduces these reference colors to how the reference light produces these samples, the higher the number. So a CRI of 100, it essentially says this light, as far as projecting onto these samples go, produce identical output as if the reference light hit these samples. So CRI measures fidelity. It measures how close your test light is compared to the reference light of the same color temperature. Okay, so CRI is simple. It's a simple number, but I have to warn you, it's like counting calories when you eat your food. If the calorie count was the only thing that you looked at on your nutritional facts on food, then it actually leaves quite a bit of other information behind that you may be overlooking. And you can see, I'm sure you guys have seen on the back of light bulbs in Home Depot and such, that the lighting facts looks awfully similar to nutritional facts that you see on your food. It's designed that way because they want to just show you the basic numbers that you need to see to make your design decision. However, just like nutrition labels, there are a lot of key ingredients that you're not looking at, and it may actually do some detriment to the intent of your design. So some of the things the CRI does not cover is the design intent and the actual preference of your subject when they of your customer when they actually look at what you've produced. And one very obvious drawback is the fact that there's only 8 color samples that CRI is testing against. So you only have 8 samples that's basically trying to represent all the different colors that you would possibly have as subjects. So CRI has a bunch of issues. It's been around for the longest. It's a simple number. That's why it's been around, and it's been really difficult to overthrow. There's been multiple attempts at trying to find better ways of measurement, but they've not been successful until recently. And a couple of other drawbacks include, the performance rating don't match the visual assessment, meaning you might have something that has a high CRI, but when you actually project it onto your object, you may actually not prefer that light. It may actually look less optimal than something else that might have a lower CRI. So if the metric is not consistent with our visual assessments, then obviously there's something wrong. You can't tell your customers to change their preference just because of an arbitrary number. So CRI has some inadequacies in that it's not matching actual customer expectations. And also, as you've seen earlier, if you only have 8 samples, then it's essentially possible to game your results in that I could perform perfectly in mimicking those colors with respect to those 8 samples, but maybe my performance is not that good if it's actually projected onto colors that are not part of those 8 samples. So it could definitely be gamed and not be good for your application. And then finally, CRI, because it's only looking at fidelity, essentially how good this test light is towards compared to a reference black body source, it inherently prefers your incandescent, less efficient light sources because incandescents are essentially black body, right? It's using a heated filament to generate the light output. So of course, that's going to mimic the ideal black body source. But that just means your more efficient sources are always going to have a metrically disadvantaged number because it's not using heat to produce the output. So it also impedes the market adoption towards something that is more efficient. So one thing to note, color rendering does not mean color fidelity. In CRI speak, CRI is trying to make it equivalent to color fidelity. But the problem is it's missing some of those earlier metrics I shared, which is preference of the user. So color rendering is encompassing how the user actually evaluates the light in real setting. But color fidelity is just trying to say how close the light is to this arbitrarily chosen black body source. So this is where TM-30 comes in. The TM-30 is trying to encompass at least the requirements of CRI, but far exceed it by starting out with 99 samples that you're testing against, not just the 8. And it's also based on a lot of new color science research from multiple industries. So there's been a lot more of a holistic contribution to this new TM-30 standard. And it's been around for close to 10 years now through multiple revisions. But the 2020 standard, which is the latest one, has some specific recommendations that's going to help designers pick the right tools for the job. So I'm going to actually read this to you because it's really important for you to understand the motivation for TM-30. As specifiers and manufacturers transition from CRI to TM-30, these specifications should result in tangible changes across the industry. Manufacturers have an opportunity to fill gaps in the market by delivering products that previously would have been challenging to specify, but that are now clearly categorized and thus marketable. Engineers, architects, lighting designers, and other specifiers now have evidence-based ANSI metrics and specification criteria so they can be more purposeful in the color rendering performance they want instead of leaving it up to chance. And finally, Owners and users' expectations can be clearly described and satisfied by appropriate products. So everyone comes out ahead. And this is published by the IES, which is the Illumination Engineers Society. So it's essentially the de facto official organization that publishes this standard. So before we get into the nitty-gritty of TM30, I want to start with the why behind this and the design intent. So as designers, you guys are going to be looking at these three primary design intent priorities. The first one is preference. And this preference is preference of the user. When somebody actually looks at this light and the objects it illuminates, we want to give a high preference if you care about how pleasant it is to the user, the naturalness, and the acceptability to the user. So this is actually going to be used primarily in retail, office, hospitality, and residential. So many of your applications actually. And in preferences, there's a slight color shift with more red saturation. And this is because of an effect called the Hunt effect, where it says they've done research where at low light levels, our eyes tend to make things seem a little bit duller and bluer. And so if we were able to compensate for that with adding some additional reds at low light levels, then the user actually prefers that type of lighting because it seems more natural. But if you're necessarily adding red, then you're essentially making this light source different from the reference light, which does not exhibit this type of red shift. So the next design intent is vividness. And this is in applications, probably more in theatrical applications, where you really want to make certain colors highlighted or popped. And that also means you're going to have some hue distortion because you're emphasizing certain colors over others. And that's going to also deviate from the fidelity because it's not like the reference source. And then finally, there might be applications where you do want the light to be as close to the reference source as possible because you care about consistency. And in these cases, such as for color matching or healthcare applications, you do want to have a high fidelity metric, which is kind of like the older equivalent of CRI. Okay, so now that we know these three design intents, let's dive into the data. So don't panic. This is a TM30 full report. Okay, so there's a lot of data in here. There's a lot of data, and we'll get into most of these pieces. And some of these pieces you don't really have to get into unless you really want to dive in technically. Now, the CRI is all the way here at the bottom. It does exist. It's there mostly for a transitional purpose so that you still have your old metrics there. But the IES recommends that all future designs wean themselves off of using CRI and rely more on the rest of the TM30 report. Okay, so let's look at a particular piece. The most important piece, even if you look at the simple report, it will have these components. It'll have these four numbers right here. The first number is going to be RF, and that is the rating of fidelity. And this is essentially like what CRI measured, but it's measuring against 99 samples instead of just 8. So it's a much better version of CRI, if you will. And how this graph works is the reference light is this black unit circle in the back. And the test light result is this round circular blob overlapping the black. And a high RF means your red performance is going to match identically to the black. So the more circular that this red is, then the higher the fidelity. So a 100 RF necessarily means that this red line is essentially completely overlapping the black 100%. Anything that is not overlapping will produce a number that's less than 100. Okay. So next is RG, the second number. This is the gamut. And that is essentially a measure of how saturated a certain color is. And this number, you have to note, can actually exceed 100. So less than 100 means it's actually inside the circle. More than 100 means for a particular color, it's actually outside of the circle, meaning it has more emphasis of that specific color component. And then you have your CCT down here at the bottom, which we've covered earlier. And then DUV, you don't really have to worry too much. It's essentially how much deviation from the ideal black body curve this light is in some other dimensions. However, if you have a high RF, this number essentially goes to 0. Okay, so you don't have to worry too much about that number. Okay, so why not just use RF to replace the old CRI and just say, hey, I want a fixture as close to 100 as possible? Well, there's a lot of drawbacks with that assumption, because we are first assuming that we want to match the black body source. But what if that's not our design intent? Because earlier I mentioned that our eyes actually have some preference to having more reds pop. And in that case, it necessarily means we don't have a high, 100 or close to 100 RF, because we actually are distorting the colors a little bit towards red. Okay. And then we also have some instances where we want more vividness, because maybe for a theatrical setting, we want certain colors to pop, and that's also not going to have a high RF. So just using that number, again, is kind of like the same fault as only counting calories. It's not going to suit your purpose when you have other design intents. Okay, so now let's look at the final two numbers you have to look at when it comes to TM-30. So there's this RCS-H1, which stands for chroma shift, and H1 stands for this first hue bin, this first one. I think there's 16, there's 16 bins, and this is the first bin. So we're only really interested in the performance on the red. And so this number you got to watch out for. And then finally, you have your fidelity H1, which is this first bin right here. Now, this RF is actually a subset of the RF I mentioned earlier in this unit circle, but it is only particularly interested in this first bin, which is red. Okay, so breathe a little bit, because this may look kind of overwhelming. We just went from a single metric called CRI into 4 different metrics. That was RF, RG, RCSH1, and RFH1. That's a lot. And if you had to do that for every single product, I can imagine that is quite time consuming as a specifier. And so what the IES has come up with in the TM-30-2020 edition is this preference, vividness, and fidelity priority levels that basically sets the requirements for those 4 numbers into these different categories. Before you dive too deep into looking at these numbers, just know if something satisfies a P1 rating, it will necessarily satisfy a P2 or P3 rating. But if something only satisfies up to a P3 rating, that means it's not good enough to satisfy P2 or P1. And in particular, for the preference rating, this evaluation came through a bunch of real-world experiments where if something has a P1 rating, then more than 90% of people will find the light acceptable. If it's P2, then more than 80% will find it acceptable. And then if it's P3, more than 65% of people will find this light source acceptable. Okay, so now we have these different metrics, and how you actually will specify this is, instead of looking at the numbers in here, you first start with looking at what's important for my design? Do I want this to be in a hospitality application? And in that case, maybe I require P1 rating on all of my products. But I probably don't need things to pop, with really vivid colors. So this is not important to me. So I may not even have a V requirement on here. But I do want the light source to mimic as closely as possible to the reference source. And maybe in this case, I think F2 is good enough, right? So in this case, you might have a P1 F2 requirement for your design. Now, it's also important to note, of course, we want the highest priority level of everything. But two things to note. One, it's impossible to achieve all three top priority levels simultaneously. And also, the higher you have your requirements, the lesser available products there are on the market that will match your requirements. Okay, so let's look at what this actually looks like on this quasi Venn diagram. So the different requirements for preference, fidelity, and vividness rating slightly overlap in certain areas, and some are impossible to overlap. So for example, a P1, V1, F1 rating is actually impossible to hit, because if something has a high amount of vividness, then it necessarily means it's not going to be high fidelity, because it means it's distorted the color. So these requirements are going to be almost exclusive, mutually exclusive. And then here is a very high-level generalization of where a lot of the lighting technologies lie as far as their performance ratings. So if you look at color mixing lights have pure colored lights. So obviously they're going to make certain colors pop. So they're really good at filling in this V1 metric. And then you have incandescent lights, which essentially are very close to black body. So that's going to give you, your high fidelity levels, and also very often very high preference levels. And then white LEDs and fluorescent kind of covers this range. And you'll see some of them, they do satisfy your high fidelity and high preference requirements, but many times they lie outside of it. So what that means is if you require absolutely a P1, F1, there's just going to be less products available on the market that you can specify that satisfy your design intent. Okay, so now I have to just really emphasize this, that the TM-30-2020 edition is totally new. It just was established last year. And so there's not a specific format for manufacturers to produce their PVF ratings for you. There is a standard for their TM-30 reports, like that full report I showed you earlier. So that's standard. But in order to get PVF ratings, you basically have to scour that full report for the 4 numbers that I've mentioned to see if it satisfies your requirement. And also many manufacturers, they still show the CRI just because, that's the status quo. But the IES is highly recommending transition away from CRI into TM-30. So Gantom, our company, we are trying to bridge that gap with our new data sheets, in that we do provide you the full TM-30 report, so you can check it out on your own. However, we're also going to feed you the PVF and ratings directly on the data sheet, so you don't necessarily have to dive into the detailed numbers. So the intent is later on, as more manufacturers pick up this way of showing it off on the data sheet, you may not necessarily need to calculate these numbers internally. You just need to know, do I want a P1 F2 or a P3 V2 or whatever your priority levels are. And then you look on the data sheet to see if it meets or exceeds those design requirements. Okay, so for example, let's say we want a P1 F2 fixture. So then we check the data sheet. And this is a sample of new dynamic white fixture data sheets that we are producing. And so you'll see right here, front and center, we try to give you the priority levels for the preference and the fidelity. And you'll see at certain color temperature configurations, we're able to hit a P1 F2 rating right here. And for those who want to dive further in, we also give you the exact 4 numbers that will satisfy these ratings, right? So you can actually look in there and see those numbers yourself. And then on the very back of the data sheet, we do have the full TM-30 report, so you can dive in to see the graph and how circular the test reference circle is. And of course, there is the CRI, but again, we're trying to wean people off of it. We have this just like many other manufacturers, just because it's kind of the current status quo. Okay, so now here's an aside. What is official? What makes something official? As far as the TM-30 and many other standards go, they're not necessarily created by the government. They're not official, actually. They're created by these work groups that are composed of industry professionals, people who basically have a stake in the industry and have a stake in the game. Now, regulations are often written referencing these industry professionals. They're going to bring in consultants and such, and the consultants are going to refer back to these standards because it's been studied, it's been worked on, right? So it's at that point that the government or these local agencies may institutionalize some of these standards and say, okay, for our projects, we need things to hit a certain metric or use TM-30 and whatnot. And so once there's more adoption, that's essentially what makes something official. So the extent to which something is official is really dependent on how many people in the market adopt this thing as being official. So really, it's driven by you, the customer, or the specifier. So if you're asking for the data for PVF, then eventually all manufacturers are going to show the PVF ratings. So these are our recommendations to really help make a positive change in the industry. Ask your manufacturers, including us, for PVF ratings. And this is similar to how the food labels have changed over the years. Now, when you go to the market and look at the food labels, there's going to be a lot more badges on there talking about this is organic, non-GMO, what ingredients it does not have. That's because the consumers care about that data. They care about these nuances that are beyond the nutritional label of just calories. And because consumers are asking for it, the manufacturers are eventually adding that data on there as part of marketing, right? They want to sell more products, so they want to show you that their metrics are hitting exactly the requirements you guys, the specifiers, are looking for. So if you guys are asking for the PVF ratings and then the manufacturer comes back clueless, we'll simply just share with them the TM-30-20 standard, and I'll have a link to that. But be forgiving, don't be condescending to them. Just tell them this is a new standard and you're going to expect them to hold to that standard. So send them that standard so they can look at it and improve their documentation. And so lastly, just to mention that, everybody needs to be persisting in this effort and asking for PVF ratings and TM-30 in order to get manufacturers to collectively make a change. And once there's enough momentum, even new manufacturers coming into the space, they're going to see, oh, the TM-30 is official, so I should do it. So you're going to have more and more adoption as we all persist in pushing this effort. And so I'm going to leave you with some final resources. Some is homework. I definitely recommend you guys take a look at these 2 links from the IES. And one is the first link shows you specific examples of how to specify using this new TM-30-20 standard. It goes through some details in a lot more detail than what I'm sharing here. And then finally, the second link, this is the IES store where you can actually download for free the TM-30-20 standard, and you can share that with other manufacturers, or at least send them the link so they can get it for themselves. And so with that, I want to say thank you for your attention. Hopefully you learned something from this, this talk. And also I wanted to mention that if you guys have any needs for lighting equipment from Gantom, there's compact LED DMX controllable fixtures. Here's a link. You can go to gantom.com/demo and you can schedule a call with us. We'll be able to give you a demo over the web, and if needed for your application, we can even send you some samples. So I wanted to thank you again for this opportunity to teach and also learn from myself. But yeah, hope you have a great day. Take care.